In this lesson, we're going to have a brief look at the periodic table. Now, the periodic table is a table of the chemical elements, and it is arranged in order of what we call the atomic number. Now, the atomic number is the number of protons that there are present in the nucleus of each atom. Now, we're not actually here to talk about atomic physics, because that's really high school physics or IGCSE course level. We're still really at the moment in middle physics, and atomic chemistry or atomic physics will come later. But what this really means is that, for example, the atom hydrogen has one proton, so it has an atomic number 1. Then the atom of helium has 2 protons in its nucleus, lithium has 3, beryllium has 4, boron 5, etc., and counting onwards up and up until we reach radium down here, which will have exactly 88 protons in its nucleus. Okay, before we look at those trends then, let's just have a look and see what we mean by a period and a group. So, first of all, the groups are the columns that go downwards. So we call this will be group 1, and these are usually allocated Roman numerals. So that would be group 1. This will be group 2, headed by beryllium. Then group 3, headed by boron. Then group 4, headed by carbon. Group 5 by nitrogen. Group 6 by oxygen. Group 7 by fluorine, and then I can't quite fit group 8 in here, but I'll write that by the side. This is group 8, which is the noble gases. We'll talk about the names of the groups in a minute. Yeah, and going across each the periodic table, we have the periods. So the first period has only 2 elements in it. That's period 1, and then the next period, period 2, has 8, then period 3, then 18, period 4, and period 5, and then we have period 6, and finally at the bottom period 7. Now, so what we're saying here is the physical and chemical properties of the elements follow trends or patterns, okay, A, across each period, and B, as you go up and down each group. So it's very important to get to know this periodic table so that you can literally predict, the physical or chemical properties of a given element, knowing where it's positioned in the group. For example, just to take a physical property such as the diameter of each atom in the periodic table, or the atomic radius. Now if we have a look over here, you can see this is a periodic table according to the radius of each atom, imagining that each atom is a ball, okay, and you can see that clearly there are patterns, and as you go across each period, right, starting for example from hydrogen through to helium, and then from lithium through to neon, you can see quite clearly that the size of the radius decreases as you move across the period. Likewise, the same thing happens in period 4s, 5 and 6. There is a gradual reduction in radius. Now, I'd like us just to have a quick look at this middle block here, and you'll notice that within this block there are in fact changes in radius, but the changes are actually quite gradual. So there isn't a whole lot of change going on here. As you jump from group 1 through to group 8, there are quite radical changes in diameter. Now, because of these slow gradual changes, this block has become known as the transition elements. Okay, these are the transition elements. and they tend to have similar physical properties. For example, most of them have high melting points, quite high densities, so they have high melting points, high densities. Likewise, you can also see here within the groups that the atomic radius is clearly increasing as you move down each group. So there are patterns going this way and patterns going up and down the group. Now, I've removed the transition block from the periodic table for just this minute, and we're going to have a look at how the chemical properties change as we move down, for example, group 1 and 2. So we can say that as we move down groups 1 and 2, there's a tendency for the elements, or the metals, to become more reactive. So reactivity increases. Now, if we look at groups 6 and 7, for example, then the opposite happens. Okay, we can see that the reactivity of the elements increases, not as we move down the group, but this time it increases as we move up the group. So we can make predictions about the chemical behaviour of various elements. We can say, just looking at the periodic table, that we would expect potassium to be more reactive, for example, than sodium, or calcium to be more reactive than magnesium, which they are. Likewise, we would expect chlorine to be more reactive than bromine, or oxygen to be more reactive than sulfur. Now, we will look at each of these groups individually in the following lessons. What is important here is to understand that the periodic table is an organised arrangement of the elements, and that within this periodic table there are important trends and patterns that help us to predict the behaviour of the various elements within it.